In this video, you will learn about exponents. Now, exponents is a quick way to write a multiplication problem. Now, it's a specific type of multiplication problem where you're multiplying the same number over and over again. So let's say, for example, we are multiplying 2 times 2 times 2 times 2 times 2. So you're multiplying the same number over and over again 5 times. Well, the number 2 we learned in the past is called your factors. The numbers you're multiplying together, those are called factors. What we can do is we can write this in exponential form, or with an exponent. So the way we can write this would be as a 2, and then we have 5 2's being multiplied together, so we put a little 5 up here above the 2. That little 5 is called an exponent. So we see it typed up right here, 2 with a little 5 above it. 5 is the exponent, and then 2 is called your base. So 2 is the base. Base usually means the bottom of something, like basement, right? The basement is the bottom of a house. So the base is the bottom. And then the exponent is the little number up here. So it's just a quick way of writing the same thing. So instead of writing out 5 2's like this, as 2 times 2 times 2 times 2 times 2, we can write this as 2 and then 5 as your exponent. Now in English, the way we would state this expression right here is we would say 2 to the 5th power. All right, 2 to the 5th power. So 5 is your exponent, so that's to the 5th power. All right, let's try a couple other examples to get practice with this idea of exponents. So on the left, we're going to have our factored form, which would be like what we have up here with just factors, right, with these numbers multiplied out. And then on the right side, we have what's called exponential form. So we see the word exponent in here. So exponential is the adjective for exponent. So this would be exponential form. So for example, let's say we had 3 times 3 times 3 times 3. How would you write this with an exponent? How would you write this in exponential form? Well, the way we do this is the base is 3. Right? The base is 3. The exponent is going to be a 4. So we can write this as 3 to the 4th power. So the 3 is the number being repeated. So the 3 goes on the bottom. And there's 4 3's. So the 4 is going to be your exponent. And again, in English, we would state this as 3 to the 4th power. Now, what if we had 6 times 6 times 6? How can we write this in exponential form? Well, here the 6 is the number that's being repeated. So you put a 6 down as your base. And how many 6's do we have? Well, we have 3 of them. So 3 is going to be your exponent. So we have 6 with 3 as the exponent. We can state this as 6 to the 3rd power. And we see that typed up right here. All right, now, what if we had this expression? We have 5 to the 2nd power. How would we write this in factored form? So we're going the other way. Well, 5 is the base. Okay, that is the number that's going to be repeated. And how many 5's do we have? Well, we have 2 5's. The exponent is the number of 5's that we have. So we have 2 5's multiplied together. So 5 times 5 would be your answer in factored form. Here's another example. What if we had 4 to the 3rd power? 4 to the 3rd power. Well, the 3 is your exponent. That's telling you how many 4's we have. So we have 3 4's. So we take 4 and multiply it together 3 times in a row. So your answer for 4 to the 3rd power is going to be 4 times 4 times 4. So be comfortable with knowing how to convert from factored form to exponential form, and then from exponential form into factored form. And also it's important to understand the English phrase as well, because when I'm talking about an expression, this is what the phrase I'm going to use. I'm going to say something like this over here. All right, so make sure that you are comfortable with this slide. Now on the next slide here, we're going to talk about some special names. So specifically, we have anything raised to the second power or anything raised to the third power. We have a special name we give to both of those scenarios. So what if we had 4 to the second power, which would mean 4 times 4? Well, this expression, 4 to the second power, another way we say this would be 4 squared. So it seems kind of weird. Why is it called squared? Well, the reason is because if you take a square where each side is 4 units, so it could be 4 inches, 4 feet, whatever, and you had to find the area of the square, meaning how much space does the entire inside take up. Well, to find that, we would have to multiply 4 times 4. So to find the area of a square, we multiply a number by itself 2 times. So notice that's the same thing that we had over here. So because that's how you find the area of a square, that's why it's called 4 squared. So for example, if we had like 6 to the second power, like that would be 6 squared. If we had 8 to the second power, that would be the same thing as 8 squared, and etc. Anything to the second power would be squared. So 9 squared, 10 squared. Anything to the second power would be squared. Now the other special name that we have is anything to the third power. And the name we give to this would be cubed. C-U-B-E-D, cubed. So this could be stated as 4 cubed. Now why is it cubed? Where does that word come from? Well, it comes from the word cube. Because if you have a cube, that is 4 units in length and width and height. So it could be 4 inches, 4 feet, whatever. If this is the dimensions of the cube, to find the volume of this shape, to figure out how much space can this thing hold, all right, what we do is we have to multiply the 4 times the 4 times the 4. That's how we find the volume in this case. So notice that is the same thing as what we had over here. So where the word comes from is because of the shape of a cube, how we find the volume of that. So anything to the third power is cubed. So if we had 8 to the third power, that would be the same thing as 8 cubed. If we had 12 to the third power, that is the same thing as 12 cubed. So anything to the third power, we can say that as being cubed. So anything to the second power is squared. Anything to the third power can be stated as being cubed. So make sure you know those special terms. All right, we're going to give a couple examples here, and we're trying to show a pattern to get to an end goal, to illustrate something. So here, see if you can do these on your own the best you can. What if I said, find 2 to the 5th power? What would that equal? Well, that means we would have 5 2's multiplied together. So that would be this. That would be 2 to the 5th power. All right, well, what does that equal? 2 times 2 is 4, times another 2 is 8, times 2 again is 16. 16 times 2 equals 32. So 2 to the 5th power is 32. Now what about 2 to the 4th power? What would that equal? Well, 2 to the 4th power would be 4 2's, so 2 times 2 times 2 times 2. What does that equal? Well, that would be 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So 2 to the 4th power is 16. Keeping the pattern going, what if we did 2 to the 3rd power? Well, 2 to the 3rd power would be 3 2's, so 2 times 2 times 2. That would be 2 times 2 is 4, 4 times 2 is 8. So 2 cubed, 2 to the 3rd power, is 8. Now what if we did 2 squared, meaning 2 times 2, or 2 to the 2nd power? So if we did 2 squared, 2 times 2, that equals 4. All right, keeping the pattern going, what if we said 2 to the 1st power? 2 to the 1st power. Well, that means we only have 1 2, right? So like the 2 to the 2nd power is 2 2's, 2 to the 3rd power is 3 2's. 2 to the 1st power, that would be 1 2. So that would equal 2. So anything to the first power is going to be what you started with. All right, so if we had like, let's say 100 to the first power, that would be just 1/100. All right, so just 100 is your answer. If you had 9,000 to the first power, that would just be 1/9,000 or 9,000. So anything to the first power is quick to do. Just put the number that's being raised to the first power. So that's the same thing. But what I want to show also is what would we get if we did 2 to the 0 power? Well, what would that equal? So if you look at the pattern that we have, look at this column and then this column. Okay, do we see a pattern in this right column over here with the 32, 16, 8, 4, and 2? How do we get from 32 to 16, and then from 16 to 8, then 8 to 4, and then 4 to 2? What is the pattern between each of those numbers? Well, the pattern is we're dividing by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So if we keep that pattern going, 2 divided by 2 would give you 1. So 2 to the 0 power, if we keep the pattern going, it's going to equal 1. And in fact, anything to the 0 power is going to be 1. So if we had like 3,267 to the 0 power, that would equal 1. We can have the most crazy thing. Even like when you get to more advanced stuff, you can deal with letters and just weird stuff like that. We can take this weird expression, raise it to the 0 power, and it doesn't matter what we're raising to the 0 power, it's still going to equal 1. So anything to the 0 power will always equal 1, no matter how big the number is, how crazy the thing is inside that we're raising to the 0 power, it's always going to equal 1. And actually, this is a little more advanced. You don't need to know this yet, but we could actually keep this pattern going. All right. And so if you, on the left side, we could actually continue this into negative numbers. We can have 2 to the negative first power. So that's a whole nother thing, but I'll just kind of give you a sneak peek on what that would be. We keep the pattern going on the right side. We have to divide by 2. And that would be the 1 divided by 2, which is 1 over 2. So basically, negative exponents are going to be fractions. And we'll get more into that later in future years, but just keep that in mind that we could actually keep this going further. So the main thing I want you to remember from this slide is the fact that anything to the first power would just be itself, and anything to the 0 power will always equal 1. All right, on this slide, we're going to talk about variables. So this is another term that you may not have heard before. But a variable is, by definition, a letter used to represent an unknown number. So, for example, if we had like, n plus 3 equals 7, okay, n is an unknown number. We can figure out what it is, but we don't know what it is at the moment. We have to solve and figure out. So it's a letter representing an unknown number. So it could be n, it could be x, it could be any letter that we put in here. So, for example, if we had x times x times x times x, that's just 4 numbers that we don't know what they are. 4 numbers multiplied together. So it could be 5 times 5 times 5 times 5. It could be 8 times 8 times 8 times 8. We don't know what the number is, but it's the same number multiplied 4 times. Well, we can still express this with exponents. All right, just like we did if it was like 5 times 5 times 5 times 5. We just discussed that would be 5 to the 4th power, right? Same thing here. Okay, we have 4 x's, so we take x to the 4th power. So it's the same concept. We have 4 x's multiplied together, so it's going to be x to the 4th power. We just don't know what that letter is. It could be 5, it could be anything. So what if I said b times b times b? How would you write that with exponents? Well, we have 3 b's multiplied together, so we have b to the 3rd power, or b cubed. All right, that's all we do. What if I said y to the second power? How would we write this in factored form? How would you expand this out? Well, this would be 2 y's multiplied together. We have y times y. All right, so that would be your expression in factored form. So all the same rules still apply. If you put a letter in here, it's just representing some unknown number. And now to finish off the lesson, we're going to work specifically with base 10. So like what if you had 10 to the first power, or 10 to the second power, or 10 to the third power? Well, this is actually much quicker because there's a pattern that we can follow with this. So try to do this the best you can by yourself, and then see if you can recognize the pattern that we are creating. So 10 to the first power, what would that equal? So remember, the 1 for the exponent means we have just one 10. So we just have one 10, which is 10. All right, so the answer for 10 to the first power is 10. Now what about 10 to the second power, or 10 squared? 10 squared means we have two 10s multiplied together. 10 times 10 is going to be 100. Now what if we had 10 cubed, or 10 to the third power? All right, well this means we have three 10s multiplied together. 10 times 10 is 100, and then times another 10 would be 1,000. Now before we keep going, do you notice a pattern with this column and this column? More specifically, do you notice a pattern with the exponent? With the exponent and with the number of zeros? Well, notice the exponent is going to be the same as the number of zeros that we have. So if the exponent is 1, we have 1 0. The exponent is 2, we have 2 zeros. The exponent is 3, we have 3 zeros. So this pattern is going to hold anytime we have 10 to some power. So if we had 10 to the fourth power, what would we get? Well, it's going to be 4 10s multiplied together, which would be 4 zeros after the 1. So the exponent is 4, so we have 4 zeros. So if we have 10 to the fifth power, we would have 5 zeros. And the pattern would continue. If we had 10 to the seventh power, we would have 1 with 7 zeros. 10 to the sixth power, we have 1 with 6 zeros. All right, so the pattern, as we said, is that the exponent is the same as the number of zeros. All right, so 10 to the sixth power, we have 6 zeros. So that's a quick way of working with base 10. So if 10 is your base, the bottom number, whatever the exponent is, that's the number of zeros we put after the 1. And that concludes our lesson for today. We will see you next time.